Okay, this video is about properties of logarithms. One of the main pieces of this is it relies on this relationship right here. This idea of log and exponential functions being inverses of each other produces some properties of these guys. For example, right here, if I have log base b of 1, if I convert that into exponents, I don't know what this is, right? Question mark. So I want to know b to what power equals 1. And then if you remember your exponent rules, that's 0. B to the 0 equals 1. So this property is log base b of 1 equals 0. Okay, similarly, this one right here, if we convert it, we get b to the question mark equals b. Well, the question mark has to be a 1 right there. So the question mark is 1, which means this property says log base b of b equals 1. So it's kind of like a little canceling property. Okay, the next one says property, converting it, property. I don't even know where that came from. B to what equals b to the x? B to what equals b to the x? Well, that's silly. X or the question mark equals x. Okay, so now this property actually turns into log base b of b to the x equals x. It's almost like the log base b and the big B cancel each other. Same for this thing, log b to the power, log base b of x equals x. We won't use that one very often. Okay, then over here with natural logs, it's the same. This just says e to what power equals 1. So the ln of 1 equals 0. This one says e to what power equals e. Has to be 1. So ln of e equals 1. Same thing here. E to the what equals e to the x. E to the what equals e to the x. So the ln of e to the x equals x. Again, it's like they cancel each other out. And then likewise for the other one. Okay, so as far as these properties are concerned, they're all important, but one of the main ones that we're going to be using is this one right here. When you have something to a power and you take the log of that something with the same base, then basically they cancel each other out. So let me show you some. Right here, this says log base 3 of 3. Now technically that's to the 1 power. So these guys cancel and your answer is just whatever that power is. This one right here, e and ln basically cancel each other and you get pi. Okay, log base 8 of 1, that was the one that said 8 to the 0 power equals 1. So my answer here is 0. Okay, log base 2 of 25.25. This one's a little bit trickier because that's 1/4, which is 1 over 2 squared, which is 2 to the negative 2. So this is actually log base 2 of 2 to the negative 2 power. And again, that important property we have says these guys cancel each other out because they have the same numbers there, which means negative 2 would be your answer. Okay, the 4 and the log cancel because they have the same base, which just means 8 is your answer. ln and e cancel each other, which means 5 is your answer. This one's a little bit different because we've got e down here in the denominator. Well, I'm going to rewrite that as e to the negative 2. And then the ln and the e cancel each other. Whoops. Hit the wrong button. Ln e to the negative 2. Are you kidding me? I didn't do it. Okay, then the ln and the e are going to cancel each other. And all you're left with is that power. 10 and log, when there's no number written, it's base of 10, so those cancel, and your answer is 25. This is log base 3 of 81. We need to write it as log base 3 of 3 to some power. 3 to the 4th is 81, which means these guys are going to cancel, and your answer is 4. I don't know why I circled that one and not the others. So again, this property right here, this idea of if you take the log with a base of b, and inside it is the same base with something up in the power, that just equals the power. It's kind of like a counseling tool. It's another way to get those x's out of the parentheses. Okay, now some other log properties. Oops, I must be hitting the button. So these properties are just ways of rearranging them, and this is the usefulness of logarithms. The first one is just an explanation of the relationship between logs and exponential functions. This first property right here, the product property, says when you have a log, base whatever, of two things being multiplied together, you can actually split that into two logs where you separate the a and the b and you put a plus in between. So it's not really distributing, but it's splitting the a and the b up, and it turns out that the log base m of a plus the log base m of b would be the same as if they were being multiplied inside. So here's an example. Log base 4 of x times y equals log base 4 of x plus log base 4 of y. That plus is the thing that you have to remember. Because we also have one for quotient, a fraction, that says if you're taking the log of a fraction, you can actually split them up into their own log, and now we're going to subtract. So this is the key here. Example, log base 5 of x divided by y turns into log base 5 of x minus log base 5 of y. Okay, the next one is a power property. This one is very useful and we're going to use it a lot. It says if you have the log of something to a power, then that power can actually move out in the front. So that then it would just be the power times log base m of a. Here's an example, log base 10 of x to the third. This power, it doesn't matter what the bases are, the 10 and the x don't matter. It's this power can be moved out in front so that it's written as a regular old 3. And then you copy down the log. Then there's this inverse relationship that I told you was important. Whoops. If you have log base m of m, so the same base, remember those guys basically cancel each other and you're just left with the power. And then it works this way as well, where you have m and it's raised to a power, but we're not going to use that. So example, log base 5 of 5 is going to equal 4. That's going to be one of the ways that we get the variables out of the power. Okay, let's practice. Sometimes what you're going to want to do is expand it, which means I need to rewrite this as separate logs. So this is multiplication. And the property says for a product, right, multiplying inside the parentheses, I've got a 4 and an x being multiplied. So basically, everybody gets their own log. Log base 3 of 4 plus, because it's multiply, log base 3 of x. Everybody gets to have their own logs. Okay, looking at this next one, I've got 1, 2, 3 things that are being multiplied. So I need to have 3 logs, 1 for each of them. Then I'm going to look at it and say, okay, it's multiplying, so everyone is going to be added. And then also, if you happen to look at this last term, there's a power. Anytime you have a power inside a log, you can bump it out in the front. So this is actually 4 log of y, and then the rest is the same. So that is expanding. This right here in red, this is my note up here to remind you. You always do the power property last, because if I had done it here at this step, and it would be 4 times the whole log, and that's not what it's a power to. The 4 is only a power to the y, so you cannot do it when it's until it's expanded. You just do the powers last. Okay, this one's a little bit tricky. You have to remember that a radical can be rewritten as a power, right? Y to the 1/3 is the same thing as a cubed root. So I've got 2 things. It means I need 2 logs, log of x squared, log of cubed root of y, and they're multiplying. So I'm going to add. This is log of y to the 1/3, log x squared. Now I've got 2 powers, both of which are going to move out in front. So this becomes 2 log of x plus 1/3 log of y. This whole converting thing, the root of y, it's always just 1 over it. So if it was square root of y, that would be y to the 1/2. If it was the 5th root of y, that would be y to the 1/5, and so on. All right, let's try the other one. Now we're going to squish it back together, right? We've got this log that's spread out. See how there's a pluses in between? We're going to put it back together as a log and nothing outside of it. So the property here, right here, and here, and here, said that if you have a power, you can move it out in front. Well, that reverses here. If you have a number out in front, that moves to be a power. So this equals log of x squared, log base 10, because there's no number written. So anytime there's a number out in front, you're going to move that to be a power. Right? Log base 4 plus log of x squared. Now we're going to join those together. Instead of writing it as 2 separate ones, like we're writing here, we need to put it back together into that spot right there. So it turns out you multiply when it's add. So I'm going to write it as a single log. But inside here, I'm going to take 4 and multiply it by x squared. And then you just write that as 4x squared. So it was plus, which means I join them together inside by multiplying. Okay, I'm looking at all of these and I'm saying, is there a number out in front? Yep, that's going to become a power. No number there. So we are at log of x plus log of 2 to the 3rd plus log of x plus 3. Now, just a side note, you cannot distribute log through to that x and 3. There are specific properties for these guys, and that is not allowed. So combining them together, this is technically 8. So log 8, x times 8 times x plus 3. And then you combine those together,